Okay, real life. Good morning, good afternoon, good evening, wherever or whenever you are watching this webinar. Thank you so much for tuning in. I'm Stephanie, and together with Muriel, we will be hosting this webinar brought to you by Scientists for Future NL. This is the first webinar of the series we named Future Scientists. And in this series, we hope to strengthen the bridge between more or less the natural sciences and the social sciences regarding everything climate change related. And in this way, we try to explore how to move forward in the decisive decade to come. So a bit about the structure of these webinars. We will always start with a presentation of about half an hour by one of our guest speakers. And then there will be a Q&A session where we will be using Mentimeter. So we'll have a quick look at Mentimeter before we start. So we're sharing the Mentimeter we're using and also the code. Should be coming up any second. So you can go to mentimeter.com, and the code, you can see it here in the top of the screen. If you type in that code, you will get access to the Mentimeter. And you can either use your browser or you can use your phone. And we'll start with a quick question for the audience. So just to get a feeling of where we are at. So on a scale from pessimistic to hopeful, where are you at regarding the future of our planet? So there's a bit of delay probably between this recording and the YouTube live stream. So we'll take a few minutes to wait for your responses. So just go to menti.com is the website and answer this question. And of course, with the future of our planet, we mean the future of our planet for us humans on Earth, and not the future of the planet itself. We will probably, that one will exist for quite some time. Let's see if we get any response. If the screen is started. There we go. So we're a bit in the middle. I also have to say this is our first webinar series, so if anything technical goes wrong, then we only learn about it and then learn from it, and then next time will be better. So yeah, I guess the scale here is up until 10, right? I don't know actually, but it looks like we're a little bit in the middle with a mixed audience. Some people are a bit more pessimistic and some people are really more hopeful. It probably also depends a bit on how detailed you interpret this question. I think there are many different ways of thinking about this. But this is Mentimeter, so we will use this for the webinar, also for the Q&A. So you can, during the presentation, you can already ask your questions there. You can use your name or do it anonymous, that's both fine. And you can vote each other's questions. So if you do that, then we're more likely to ask the questions with a lot of votes first. That's about Mentimeter. Let's now move on to our speaker of today. I'm very happy to introduce Paul Behrens. He is an assistant professor at Leiden University in environmental change. And he recently wrote a popular science book, The Best of Times, The Worst of Times, Futures from the Frontiers of Climate Science. And this book will also be the focus of his talk today. So I'm super excited to hear his presentation, and thank you so much for joining us, Paul. You can turn on your camera. Hi.
Hey.
And the floor is yours.
Thank you so much, Steffi. I'm just going to share the screen. It's wonderful to join you today. Let me just share that. And are we looking good?
Yes.
Ah, fantastic. Great. Okay, so wonderful to join you all today. I'm going to talk a little bit about the book that I wrote and about the research that went into writing this book. And the main sort of genesis of the book is that we see very many different framings across different popular science books of the future. And these can vary. I got up quite awkwardly onto a table and took a picture of a few of the popular science books on my shelves here and tried to order them from the more sort of optimistic or hopeful views to the sort of more pessimistic and darker views of the future. And I think, you know, we do go from the left-hand side here, I mean, not politically, but the left-hand side of these more sort of Panglossian views of the future, where the world is, yes, it's a flawed place, but things are getting better all the time. And we've always worried about the future. If it's not climate change, then it would have been nuclear weapons. And actually, you know, things are on the up, and we'll figure things out. We have endless creativity to work through our problems. All the way to the right-hand side here, we've got more sort of pessimistic views of the future. So basically saying that what we've done so far is great, but we've done that at the expense of long-term sustainability. And that long-term, if you were going to look at the full scope of human history, things are looking quite dark right now. And, you know, overall, books may sit somewhere in the middle. They might spend about 80 to 90% of the book talking about how terrible things are. And you've probably all read those sorts of books on biodiversity loss or on pollution of different sorts. And then spend the last 10 to 20% in a sort of optimistic mode of how to fix things. And I think readers sometimes come away from that not really knowing what to think, you know, well, how reasonable are those fixes? And is that the end of the problem if we make those fixes to, say, biodiversity or pollution or whatever it is? So I wanted to commit to these different perspectives from a scientific basis. And so I decided to write paired chapters. And one is the pessimism for the future. And that pessimism of the future is really, you know, continuing on as we are today. And it's not the pessimism of, say, the extreme sort of uninhabitable Earth, sort of David Wallace Wells style pessimism of RCP 8.5, but more the sort of RCP 6. If those of you who have seen the climate and trajectories that are often modelled. The other chapters, so there's paired chapters, that's the pessimistic chapter. And then the optimistic chapter is describing a hope for the future and what that future looks like if we address our environmental problems and how it means a much better world as a whole. And by doing so, I hope that readers can see the gap in ambition and also the sense for how much needs to be done. It's one thing to say this is pessimistic or this is hopeful, but it's another to see the distance between the two of them, the two different worlds that we can inhabit. So I'll go through some of the research that informed the book today and talk about some of the long-term trends that we'll see and what impacts they may have. So just a reminder of where we've come from. This is a picture of the great transition, an animation of population, energy use, GDP, fertilizer use, a lot of different human uses of natural resources. And there's even more that you can look up if you go to the IGBP. And you can see this real fast acceleration after 1950, but even acceleration before then. And of course, this has had very large impacts on the environment, from carbon dioxide, nitrous oxide, methane, the greenhouse gases, but also tropical forest loss, biosphere degradation, and acidification, all seeing those fast accelerations in or after 1950. So that's the past, that's where we've come from. That's the environmental situation that we find ourselves in. So what does the future look like? Well, you know, if we are to keep warming to 1.5 degrees, we're going to have to see something unprecedented in human history and in a very non-linear sense, really turn the tide on emissions. This is a picture from the IPCC special report on 1.5 degrees. And there's actually two lines here for what might sort of be a trajectory for limiting warming to 1.5 degrees. There's the grey line, which is slightly less steep than the blue line. Now, the distinction here is that the blue line is if we do that mitigation now, if we reduce our emissions now, and we don't wait to the future, to try and clean up the atmosphere, draw out the carbon from the atmosphere in the second half of this century, using technologies that don't really exist at scale yet. And the grey line is if we delay that, and then we assume that we have some sorts of overshoot and then correction where we draw down emissions in the future. As I say, we don't have these technologies at scale yet. Some of the sort of technological optimists think that it's not the huge problem that many foresee. But this is basically the picture today. Either we reduce now and we change the world a lot, often for the better, and don't rely on these technological options, or we sort of bumble along and we need to rely on those technological options and don't fix any of the underlying issues that we have in society. And this trade-off you can see in another animation. I've been really into the animations recently, obviously, of the possible trajectories of the future. So we can see the historical emissions increasing, and then we can see the total positive emissions in the black, and the potential need for lots of carbon sequestration by the end of the century in the green there. And so the net emissions is drawing out that carbon. And you can see the national targets, even in the worst case scenario that I've plotted here for meeting net zero by 2060, our targets are even more above that. So there's even more emissions that we may need to get rid of in the second half of the century. The other aspect of this is that the carbon capture that might need to happen is on, when I say large scale, I mean massive scale. If we use bioenergy carbon capture and storage, you're talking about continental scale installations of plants which you grow, then you take and you burn, and then you capture the carbon from those plants that they've used to grow, and then you bury it underground. There are more technological solutions called direct air capture, which would take on the order of nations, the size of nations, say the size of Ireland. We're talking about a huge amount of space. You can imagine the impact on other issues such as biodiversity. The other thing I need to mention here is that on the left, we are talking about a 67% chance of 1.5 degrees. And we need to embrace that uncertainty. There's lots to say on uncertainty, and if I had time, I'd probably talk a little bit more about it. But on the right here, you can see a recent integrated approach to sort of quantifying uncertainties in the carbon budget for 1.5 degrees. And this is the probability density for that remaining budget. And you can see that already a significant part of that probability density, that curve, is below zero. So there is still a chance that 1.5 degrees, we're already over that in our budget, and we'd have to reduce emissions in the second half of the century no matter what, and stop today. Ultimately, it seems to, taking everything in full, the amount of warming that we expect is the amount of emissions that we put in the atmosphere, but there is uncertainty around that. Equally, on the very high end, we could have a much larger remaining budget than we think. So I think that's something that we always need to bear in mind. So there's no case in which there is any scenario where we shouldn't do absolutely everything we can straight away. I think that's probably no surprise if you're watching today, but it's important to keep in mind these uncertainties around it. In fact, if you want a 95% chance of 1.5 degrees, then we already need, we've already sort of blown the budget for now, and we would have to withdraw the carbon emissions that are already in the atmosphere. Okay, but the good news is we actually already have many of the technologies we need to make this change, and the social interventions that we need to make this change, to see this very rapid, non-linear, totally unprecedented change. And solar is probably the best example of this. It's now the cheapest electricity in human history. And we've seen a tipping point in these technologies just far beyond what people ever thought possible 20 years ago, 10 years ago. You can see on the figure here, we've got the prices of photovoltaics for CSP, which is concentrated solar power, which is the mirrors in the desert often, onshore wind and offshore wind, and then the fossil fuel range is that sort of light blue range there. And you can see the massive reductions in price that we've seen from 2010 to 2021. So even if you don't count in all of the costs, the 7 million people who die every year from air pollution from fossil fuels, even if you don't count in the costs of climate change, the costs of biodiversity loss, you're looking at much lower costs to convert to renewables in the future. And this is really good news. If I plot the low overshoot scenarios, so these are the scenarios for that blue line that we saw before that don't need as much carbon capture and sequestration. If I plot the solar power that is in those scenarios here in the 1.5 degree report, then we can see that historically we're already at the higher end of those estimates. So we can see the black dots there. There's the historic expansion of PV global capacity. And they're always at the top end there. As a reminder, these are only the low overshoot scenarios. If I plotted the high overshoot scenarios or the 2 degree scenarios, we'd be way above. And then if I continue that growth into the future with the blue dots, we're continuously at the higher end of even the highest estimates for solar use around the world. And we're going to hit that industry estimate of 1 terawatt by 2023. I would have thought fairly easily. There has been some slowing in recent years, and that is a cause for concern. But there is another argument that it'll actually increase. And the reason for this argument is that now that we see such low prices, it's becoming cheaper to build new solar and new wind than to continue to operate paid-for power stations. So it's cheaper to buy the panels, the labor, the land, buy the interconnection for wind and solar, than to continue to put one more bit of coal in a paid-for power station over its lifetime. And this is a fantastic report from McKinsey, and they show what year we can expect this tipping point to happen for different countries. In many countries, it's already happened. And in the future, by 2040, everywhere in the world, it will be cheaper to do solar and wind than existing gas and coal. And that really changes everything that you might think is possible this century. So that's the good news. There's been a tipping point in the energy there, in the energy system. But perhaps now to bring it back to other sorts of tipping points, it really is a race against these natural tipping points that we see across nature and across the environment. I just want to give a little introduction here, a little introduction to what this looks like. If we have a look at the system A here, this is a sort of system landscape where the system state, very, very simply, is better the higher it is and worse the lower it is. And the conditions, the amount of pressures that we put on the environment start off very low at the left and very high to the right. So the more pressure we put on, the worse the system state gets. Now, this is a system that is linear. So this means that as I increase the pressures on the environment, the system state drops and drops and drops. So it gets worse and worse and worse. But if I decide that I want to recover the initial system, so if I want to recover the environment to the state it was before, all I need to do is just ease back on the pollution. And that will go back up in a linear way to the higher system state again. What we're more concerned about are non-linear changes in systems. So this is another way in which a system can go. A system can go from a very good state and carry along as you're polluting it pretty much fine until a very small change relates to a very large forcing at some stage in the future. So suddenly you go from one system state to a very different system state very quickly. And this can be seen in, for example, eutrophication and things like this, where just one more little bit of pollution can cause large changes in the system. What are even more concerning are these more catastrophic critical transitions, where we have a very small change that results in a very large difference in the system state. And then to recover that, we can't just push the ease back on the pollution. We can't just ease back on the pollution and allow the system to recover. So for in B, for example, if we're just beyond that small system forcing where that's written and the system state is in a poorer state, we can still just ease back on the pollution and then get recover the system. In these more catastrophic systems, we need to push back a long, long way to that point F1 in order to recover. Okay, so there's just a little bit of an intro to system dynamics there. And the reason why we're really interested in this is because natural systems often display this sort of hysteresis, which is a catastrophic bifurcation here. And this is a very sort of famous paper, commonly called the Hothouse Earth paper, which looks at the tipping elements around the world and looks at when they might start to shift depending on what sort of temperature that system is at. And so from the very low, the lower temperatures, such as the Greenland ice sheet, which is already on the move, Arctic summer sea ice, which is on the move, West Antarctic, which has been in the news recently, which is on the move, all of these start to come in at sort of 1 to 3 degrees. Then we have another set of systems which could tip between 3 and 5 degrees, and another set of systems which seem to be fairly robust up until quite high degrees of warming. And so it's not the case that scientists can't estimate the average temperature well. They absolutely can. It's more, how does the energy get redistributed under that? What do we see the changes to the landscape? What do we see changes do we see to the cryosphere? These sorts of things underneath it. And there is the concern that we've been underestimating when these tipping points might hit and how fast they might hit. And there is concern that there may be certain cascades between these tipping points. So one could be coupled to another. There was a recent article out last week that showed that actually, if you recover a system quickly enough, you may stop the system from tipping. But they didn't look at cascades again. And so this is the concern. There's a lot of uncertainty. And we don't see just technological tipping points and natural tipping points. We actually see social ones too. This is an experiment that looked at how many people it requires to shift an entire society to a new interaction with the environment. And what they found was committed minorities of people can shift the majority towards new ways of living, towards new arrangements. In this study, they found between 20 and 30% of people. If you've got a committed minority of 20 to 30% of people, you can imagine if they're 20 to 30% of people start eating plant-based diets, it might shift the system to 100%, and suddenly we're all eating sort of more plant-based diets. In the literature, it can vary between 10 and 40%, but that's the sort of range that you're looking at. There are also tipping points in activism. We're starting to see this at the moment, a real increase in the interest in activism, in getting out on the streets, in advocating for a livable future. And we can see this across all the areas of society. So we can see legal actions taken against both countries and companies. We saw one just the other day in Germany, keeping Germany to their net zero targets. And this has been increasing massively over time. There's as of, I think this was from 2019, there was 1,328 lawsuits related to climate. And this is just going to increase. And this is a tipping point because as you get more and more lawsuits, it creates more and more of a precedent for the judiciary to take more action. So if one jurisdiction looks at another jurisdiction and says, look, they've done that, we need to do that too. Another way it happens is that companies, if they want to defend themselves, they have to give their evidence, they get to give their documentation to lawyers, and then that becomes available to the entire community. So if they just want to settle, they may not have to give that evidence, disclose that evidence, but if they don't want to settle and they want to fight it, then that becomes public knowledge and could be used in other court cases. And so there's a tipping point there. And we're seeing this a little bit in finance. I mean, my own interpretation of this is a little bit rocky. It seems like a lot of this is focused on quite a bit of greenwashing, what net zero really means, offsetting these sorts of things. But they're certainly more interested in the risks we might see from climate change, from environmental damage in the financial system. Okay, so there are some of sort of the concepts that I looked at in the book, and I just wanted to move through some of the subjects now that I look at in the book. I look at population and consumption. I look at energy, food, economics, climate, and I just want to have a explore of the major trends that we see in the world. So the first one here is the really overwhelming case for easing up consumption, especially among the rich. This is work from Oxfam, from Thomas Piketty and others, showing that the richest 10% of people are responsible for 50% of all emissions. And as Kevin Anderson points out, if everyone in the EU were to live the average level of carbon emissions across the EU, then you would have cut the carbon emissions by a third. Actually, sorry, I think that's global. So if you look at any sort of consumption bucket, it's always skewed heavily to the rich. So flights, for example, in the US, 12% of people take 66% of the flights, and that's broadly the same for all high-income nations. So that's where the issue is. And actually, those people who are worried about population, they really shouldn't be, at least not for the direct reason of population alone, because it's really not much of a problem, certainly not anymore. This is a fantastic figure from The Economist, and this shows how long it takes to reduce fertility from 6 babies per woman to about replacement rate, around 2.1 babies per woman. And in the United States, we saw this took almost 100 years to happen. As time has gone on, India did it in less than 75 years. China did it less than 25 years. And Rwanda recently did most of the way in 5 years. They went from 6 to just over 3 babies per woman in 5 years. And so actually, we're seeing a massive reduction in population in high-income nations that are already starting to shrink, and a massive reduction in growth rates in lower-income nations too. And this is all down to, well, mostly all down to women's education. It's not about income. It's about women's autonomy and control over their own budgets and their freedom to organize their families. And so if you want to work on population, I would say don't even work directly on population, work on women's liberty, essentially, around the world. Okay, next I talk a little bit about energy transitions. Now, there's been this idea in the past that energy transitions take a long time, and I think that's still quite a persuasive argument. When you think of energy systems, they're very big. They span huge distances, thousands of kilometers sometimes. They are made up of huge machines. They are made up of massive amounts of infrastructure. It takes time for all of that to roll over. This is a famous paper from Gert-Jan Kramer, looking at how long it takes for different energy systems to reach materiality, to reach 1% of the total global energy supply. And you can see it takes many decades to build up. But there are reasons to think, as you might have guessed from my previous slides on solar, that this energy transition is going to look very, very different. And the reason is it's not because we're looking at large-scale infrastructure anymore. We're looking at things that we build in their millions, solar panels, wind turbines, things that look like smartphones, that see the dynamics of the data economy, rather than necessarily large spinning machinery in power plants around the world. This is a really interesting paper that's well worth a read that came out quite recently, looking at how long it takes for different types of energy systems to diffuse, how long they take to get rolled out. And if you look at the lower unit costs, it takes much less time for the energy systems to change. And that's exactly where we're at with solar. The unit costs are much, much smaller, and we can do that and learn very, very quickly about how to do it cheaper, how to do it with fewer emissions and fewer impacts. Fortunately, it also has these granular technologies, these technologies that are on a much smaller scale, one by one, individual scale. They also have a better return on public research and development. So these dots, again, they're all different types of energy technologies. And you can see the regression there. The lower the unit cost, the higher the benefit to cost ratio from that public research and development. Okay, so there's no more messing around now, but we have these technologies that are growing very quickly, that are very, very cheap. The next area that we need to look at are food transitions, and this is commonly called the Great Food Transition. There was a paper recently that described how if we don't make this transition, the food system alone will be enough to exceed 1.5 degrees. And so it's not just an energy transition. It's not just a demographic transition that we're looking at the future. It's also a food transition and an economic transition, as we'll see later. We've never seen so much change, and this will obviously need a lot of management and a lot of community responses. In the food transition, this is absolutely desperately needed, not only for all of the impacts, but also because we're seeing a lower increase in agricultural productivity over time. So this is the average yield growth for corn, wheat, and rice over time. And yes, while we're still growing how much we can grow each year, so we're increasing the amount of agricultural growth, that growth itself is coming down. And the important part for this is that this projection includes genetic modification and excludes the effects of climate change. So we need to see change regardless. This is something we absolutely need. And this essentially comes down to a land issue as well. So we've got a land deficit. We humans, occupy around 71% of habitable land, and about 50% of that is for agriculture, and 77% of that is for livestock, meat, and dairy. We're going to need that land. We're going to need that land for biodiversity protection. We're going to need it for carbon sequestration. We may natural carbon sequestration, like afforestation, reforestation. We may even need it for growing bioenergy crops. I'm not so hot on bioenergy crops. We may do that. So this is just a non-starter. We need to free up this land. We need to revert this land to nature as far as possible. And whatever model you look at, they all say the same thing. The two biggest factors here are reducing food waste and loss, and changing diets. And they're pretty much the same magnitude. So both of them are by far the largest impacts that we can have, is plant-based diets and reducing food loss and food waste. There's other things as well, like sustainable intensification, but they typically make up a much smaller contribution to the change in the future. And if we do that, I mean, this is one way in which we look towards a hopeful future where we address these environmental issues. We actually end up in, well, arguably, a much more aesthetically pleasing world that is more healthy too, because currently we are over-consuming, and we are over-consuming meat. It's bad for our health. It's bad for the environment. It's bad for microbial resistance. It's bad for air pollution. It's bad for so many reasons. And if we are able to make this change and encourage this change and not judge people as they try to change, then we may see these much better outcomes in the future for all of us. Maybe just to return to climate change very quickly, because I think one of the things that we don't necessarily appreciate is the sheer diversity of impacts of climate change already that's happening. I mean, it's kind of controversial to say so, but in a real sense, we've already lost in a way. We've been talking about climate change for a very long time now, and although we're trending downwards all the time, it's not enough to avoid some of these impacts, and they could have been avoided. This is a wonderful website where you can go on carbonbrief.org, where you can go and have a look at the extreme events near you. And each of these dots are scientifically attributed to climate change. So there's been a paper written about how this event has been exacerbated, to what extent by climate change, and it describes that event. And you can select by the different type of event. It's very sobering, actually. It's quite a hard thing to flick through. And of course, there's far more extreme events that haven't been catalogued because there hasn't been a paper published about it yet. So it's very sobering, but sometimes I return to it just to anchor myself, because sometimes, I don't know about you guys in the audience, in the Northern Hemisphere during the winter, you tend to forget a little bit in the winter. You tend to some of the days go by without so much concern. I'm talking very emotionally from an individual perspective. And then maybe exacerbates in the summer again. But this keeps at least me anchored all the way through the year. One of the things I want to point out is that, again, while as soon as we stop emissions, we stop the warming roughly, there's some uncertainty there, the changes that we're seeing in the discontinuities in the environment may not. So we'll still get some rearranging of the energy in the weather systems. And we have systematically underestimated these threats over time. This is from a very interesting paper, which looks at how the IPCC reports over time have changed their appreciation of risks of different climate factors. And this is large-scale discontinuities, that is the one I've picked out here. And you can see on the left is the earliest, one of the earliest IPCC reports, and on the right is the latest report. And you can see that what the earlier reports thought would be happening at around 5.5 degrees, very, very high warming that I don't think anybody's thinking we're going to get to, is actually going to happen or could actually happen, is there's a risk of it happening at the same level under 2 degrees now. And the reason why it's grey above is not because it's not very high risk above where the red ends, is because we don't have the data yet. And so you can see over time, we've systematically underestimated those risks. And it's really hard to imagine actually how all the risks can play together and interplay together. This is another fascinating paper where they found something like 427, I think it was, separate risks of climate change and how they could interact. And everything from economic risks, security risks, food risks, infrastructure risks, health, water, all of those risks. It's very difficult to imagine how all of that can play out. And so if we know what we need to do with energy systems and we know what we need to do with food systems, what's really stopping us? I would argue that firstly, there's a social awareness, but there's also the economic systems in which we operate that encourage the subsidies of bad outcomes and actually penalize good outcomes. And so we will need all sorts of economic transitions in the future. And I think there's more and more appetite for that than ever. A very good representation of this is Kate Raworth's donut economics model, which I'm sure many of you have seen, where we have to provide a certain amount of services for people in order to thrive without going over those planetary boundaries, the climate change, acidification, all the different types of thresholds which we can move over to and see a critical transition that we talked about earlier. My own concern is what happens when we see trade-offs here in an uncertain world. Say there are some thresholds, but we don't know where those thresholds are perfectly. And so we say, actually, for the short term, we might trade off health for income and work, or we might trade off, we might produce a little bit more food here in order to produce more income and then potentially have more climate change. So there are these horrible trade-offs between them in how we think about this. And this may mean moving away from the current ideas of optimization, of optimizing some sort of number, some sort of pricing system, to something that's more legally binding, something that's more judicial that we talked about earlier. So I'm talking about rights for environmental conditions or for environmental locations or natural locations. Just a couple of slides off to the end here. I wanted to just reflect on this social awareness, because I think, although if you're tuning in today, you're obviously clearly really interested in this stuff, if not working on this for your entire life, I think there's still a really yawning gap between the appreciation of how this is the story, climate change and biodiversity loss and our environmental crises that we face are the story of this millennium. I mean, a lot of the impacts are going to go beyond 2100. They'll go even perhaps up to 2300, perhaps even further. And you would think that we'd be talking about this a lot. But this is a figure of the total amount of minutes of coverage on 4 major US networks. And you've seen an actual reduction of a discussion of climate change in recent years, down to 112 minutes last year. I mean, this is shockingly low. And there's research that seems to suggest that people's baselines, what they expect from the weather, changes over time. And so if they expect a certain sort of warmer weather, then they may not notice that the climatic regime is actually changing. And so actually within about 8 years, something that seemed remarkable may seem like your average, your everyday. Now, I'm not sure that still holds true in a world of wildfires and massive sort of extreme events that we're seeing in, say, Australia, California, Madagascar, these places. But it's something to bear in mind in terms of people's attention. We're really fighting for that 80% of people to be engaged 100% of their time. And there's a lot of concern about sort of doomism and concern about denial, but it's really those 80% concerned but under-engaged that I think is important to harness and keep in mind. And just to maybe end on a sort of a more positive note here, or maybe a mix. I never thought I'd see current policies yielding something under sort of 3 degrees quite consistently over time. And this is a figure of climate action trackers updates over time, including some of the more recent net zero targets. And you can see that some of the more optimistic net zero targets see 2 degrees by the end of the century. And as we've seen before, it's a real race, because that 2 degrees is really not safe. It's not somewhere we want to be. And we've seen over time, we've systematically underestimated what the climate impacts could be at lower and lower temperatures. And so we don't want to be at that 2 degrees. That's solidly in one of the higher risk areas of that figure that we saw before. So there is that gap, but I never thought I'd see the optimistic targets reaching 2 degrees so soon. The main thing is to keep countries to that, judicially and legally. So actually taking action, legal action against countries if they don't make it. Because at the moment, a lot of these targets are really just non-binding. The only thing that that countries have to worry about is the opinion of other countries. And so, and this just reiterates the point. We're probably below a worst case scenario that we saw before, but we're certainly not on the scenarios where it's still on scenarios that are very, very troubling. And finally, I think we can't neglect the role of power and influence and media in this conversation. And this is a figure from ExxonMobil many decades ago, already knowing about climate change, already knowing about the impacts, already preparing some of their infrastructure for climate change, and yet keeping it quiet and mounting a public disinformation campaign. And there'll be so much change in the next 10 to 20 years, regardless of whether we make the changes to the energy and food systems or we see intensifying climate impacts, that there will be many, many winners and losers in this transition. And we have to be really careful from a political perspective. I think some of the political scientists are only just getting their heads around what climate means for politics going forwards. And I am actually very encouraged by more democracy, not less. There's this argument that actually we need sort of dictatorial governments to make us do what's best. I'm not so sure about that. When I look around the world at the areas that are actually lowering absolute emissions, a lot of them are democracies. And if you have a look at what happens when you actually have a better democracy and you actually involve people in the science and in the decision-making, you get results that you could never imagine. So this is a climate assembly that happened last year in the UK. Scientists told the citizens selected from all walks of life across the UK what the situation was, and they asked them, what do you want to do about it? And what they came up with, this citizen assembly, was something far beyond what most politicians were discussing, what most policymakers were discussing. They're saying tax frequent flyers, get rid of SUVs. Yes, we can consider some cutting down of meat. I mean, stuff that was way beyond where we thought politically possible before. So engage people, give them the science, more citizens assemblies, please, better, more robust democracies, I think is probably the best, most hopeful response to some of this that we've seen today. So I could keep talking for a very long time. I won't. I already realized I'm a little bit over where I wanted to be. So I just want to leave it there and say thank you. And also that no matter how bad it gets, there's never a point at which doing everything we can possibly do doesn't matter. Every action matters, every bit of warming matters, every year matters, and every choice absolutely matters. And so to keep that in mind going forwards. And I'd love to take questions if there are any.
Thanks a lot, Paul, for your nice talk. First of all, I want to encourage everyone to go to Mentimeter. If you have any questions, then you can post them there. I will repeat the code now. The code is 9820-8636. Once again, 9820-8636. I already saw some nice questions coming in, but I will first start with one of my own that I had in my mind, because I've been reading your book, and when I first started thinking about the climate crisis, and I think that's what happens to many of us, is that it's such a complex problem. There are so many things and they are all interconnected. And so I think in your book, you give a really nice overview of how, which different aspects are there, which we have to keep in mind. And also in your talk, you did this. And I think many people mention is one solution is not enough and we need a complete systems change. And I was wondering whether you would agree to this, that we need this systems change, and what do you think that this would encompass, such a change?
Yeah, it's a great question, and it's this constant difference in views between the individual and the system. But systems are made up of individual choices, so they both change together in a very sort of complicated way. As we see more and more people making more and more changes, the system responds, and then we see these tipping points, as we've been talking about. So, for example, there's been a huge growth in the interest in plant-based diets, and instead of it being a situation where people have to give up things, the companies and food producers are responding with really interesting new food that's available on the market. And that encourages even more people to eat plant-based diets, because you don't have to rely on the one vegetarian meal perhaps in the restaurants that you usually go to that's the same vegetarian meal, which for so long was the case. And then suddenly you get to that tipping point, and then you see a very rapid change. I didn't think we would see such rapid change in plant-based diets, for example. So it opens up the chance for more and more systems change. So the systems changes can be somewhat emergent from this. But I think there are some critical lever points in finance and where investment goes, and in legal actions, which really do allow for a restructuring of the economics and the productive systems that we currently live in. And I think we'll start to see more and more of those as those people in those areas get interested, get concerned.
Thank you. So I saw a nice question of someone in the audience. I don't know who asked this question, but I'm sure they will remember. The technological trends that are indeed, that you mentioned are indeed hopeful. However, with total consumption going up, I'm afraid it won't do the job. Shouldn't we talk about degrowth of the economy?
I went past the energy slide, and I meant to say that it's not just about solar and wind. We need to hit a supply and demand side both at the same time. And we need to stop messing around with maybe ineffective schemes for, say, building insulation, for building retrofits. In my view, enough's enough. You know, the economic incentives for this aren't working out. You've got split incentives between landlords and tenants. You've got all sorts of different regulatory issues. Just go and do it. You know, take that debt onto the balance sheet of governments. You're going to need to see every single house, every single opportunity for energy efficiencies there. If you want to call that degrowth, I'm absolutely fine with degrowth. I think it's a nice concept to try and take the stigma out of growth, in a sense. You know, if you're not arguing for growth in the political and media narrative, then you get penalized. And I think degrowth is a way to take that stigma for saying we don't need growth out of it. I think just generally we want to decouple our productive systems so they don't rely on growth. So pensions don't rely on growth, or they don't rely on, say, extractive industries. And it's a question of where do we degrow and where do we grow? You know, we need to degrow certain sectors of this economy that we can't change fast enough, like flying, for example. There's just no real chance that that's going to continue soon. So we need to degrow that, you know, and I think that's absolutely something we need to look at.
All right.
About.
So I think I think broadly speaking, we can distinguish two crises. One is the climate crisis and the energy crisis, of course, but the other thing is the ecological crisis. And I was wondering, these two are also interconnected, of course. And I was wondering whether you have any idea on which one we should focus, or which one deserves most attention.
I mean, to some extent, I mean, it's an easy answer, but to some extent, they come together. There are areas where there are trade-offs. There was an interesting paper by Sonta et al., if you want to look it up, about biodiversity impacts of mining for raw materials in renewable energy. So there are areas of trade-off. The sense is that overall, shifting to a cleaner economy results in much better ecological outcomes, because the climate impacts can typically swamp nature. You know, I mean, already land animals are moving. I think it's something like 6 to 7 kilometers north every decade due to the rising temperatures. Marine animals are moving, I think, around 60 to 70 kilometers north on average, or sorry, towards the poles, I should say. So, they're both very, very important, and one supports the other. And I think that's why we need to get to this vision of not just relying on technical fixes. The more we delay the social change we know we need now, about inequality that we talked about overconsumption that we talked about, the more we have to rely on more technological solutions in the future, which may give us even more problems in the future, like progress traps is what they're often called. We implement something else and then we realize, oh, crap, we've got a problem with this. So for example, relying on carbon capture and sequestration on a large scale, or geoengineering, which is being talked about now. You could put, sulfates up into the atmosphere and then continue to see the oceans acidify. These are the sorts of things that, you see if you don't actually fix the underlying problems, address the underlying problems that are actually just quite bad for us anyway. The overconsumption of meat, the overconsumption of harmful pollutants, fossil fuels, and things like this.
Yeah. So I think you already mentioned that there is this bottom-up approach that we can have. So some changes should come from society, and of course you already did quite your share, I think, with writing your book and asking for attention to this problem. And I think what other scientists what are other things that scientists can do to accelerate the needed transition is a question from the audience.
Oh yeah, this is a really hard one. I don't know about you guys, but I struggle with this all the time. Like, what's the best that you can do? What's the best choice to make the change that you want to see? And I think it comes down to the fact that there's never any one best way. We all have our different strengths. We are all contributing in our different ways. We have the inner life that we can change, and the external life. So without getting too spiritual, and I struggle with this myself as well, you have the inner life and how you react to that world and explore new ways of living. I ate meat for 20 years of my life, and then I changed. And that for me was a journey of exploration and change and some difficulty. And I haven't gone full vegan, and I would like to. So you have your internal changes that you can make, which then change the way in which you view the world and feel and act in the world. I used to fly. And every time I used to get on the plane, I used to get worse and worse and worse. And then I stopped flying, and things are much better. So there's the internal stuff, and then there's the external stuff. Like, how do you change the world around you? And I think really fundamentally, the most obvious thing is just talking about things all the time. And instead of giving people a whole dump of information, which I did today, but that's just because, it's Scientists for Future, and, that we're all, scientists, a lot of scientists are watching. Instead of doing that, connect on emotional levels. So talk to the family about how concerned you are, how it makes you feel. And I don't necessarily buy that fear is a terrible motivator, as long as you follow it up with hope that people don't feel doomed. I think hitting people with the facts, and they are disturbing, and it is really a public mental health crisis waiting to happen amongst our students, amongst staff, amongst scientists. It already is a crisis. It is worrying, but we need to follow that up with the hope for the better future that, we've been carrying on like we would eventually get to that better world that we imagined from, I don't know, Star Trek or whatever, a post-scarcity society, a society where things are equal, and people are fulfilled and are able to reach fulfillment. But we actually have no excuses. We need to get there now.
I think people can really relate to that, like this anxiety that is coming up now, and it's probably not going to get better in the near future. So another question from the audience is, what can we do about the huge gap between the population that seems in favor of climate action and policymakers who argue that climate action should be slower to steadily build up public acceptance?
Yeah, this is that power question that talked about at the end there. People who are typically insulated from the harms and the effects of climate change, of environmental harms, are going to be slower to react than the people who are exposed to harms. And usually that is a certain subset of society, richer, white, male. It's not because they're terrible people, it's because they don't experience the risks. And so diversification in policymakers is a really key one, especially women in policy making bodies and in governance. And the representation of small island states, states that are facing climate change in a sort of existential way very quickly. I mean, one reason why we're even talking about 1.5 degrees is because the small island states came together and said, look, this is 1.5, don't talk about 2, 1.5, and we're in trouble, you know. So, and held to a higher standard. Yes, you can say that's all rhetoric and greenwashing and companies are now getting on top of it, but they changed the narrative. And by changing the narrative, they changed the systems and the people involved in those narratives. So it's about challenging the existing power about how fast people want to go. And I think things like climate assemblies, you know, they show a way to get around some of the political blockades, because if you can get climate assemblies, groups of people saying democratically, we want change, then politicians can use it for bad too, but they can use it for good. It's a way to get around the political impasses.
Okay. Another question is, how important is the role of finance, so banks, insurance, pension funds, and how come they are typically so behind on climate knowledge and action?
Yeah, that's a great question. I think they're really, I mean, they're fundamental. I mean, once you start to see some of the big dominoes fall there, you will start to see even faster change. And it doesn't mean that all of the efforts up to there haven't been worthwhile. All of the efforts up to there have led to this, the dam breaking. I mean, that's a terrible metaphor for right now, but the dam breaking and all that, the rest of that change. And you can see central banks already turning away from fossil fuels. You know, so the European investment banks, for example, the US Development Bank, all of these are turning away from investing in fossil fuels. Japan recently announced that it would stop investing in fossil fuels. There are some laggards still, and there are some fine print in there, like, oh, we'll stop supporting coal, but we might support gas. You know, that sort of stuff. But typically it's all going in one direction. And so the financial system is changing for that. There's also a group of, I think, around 40 countries now, the central banks of 40 countries, who are looking at rating carbon intensive sectors differently to other sectors. So what that means is that banks can earn less money on existing carbon intensive sectors than on low carbon intensive sectors. And so that will really restructure economies if that goes ahead as planned.
There's Steffi. Thanks a lot, Paul.
Regarding the time, I think we will wrap up the Q&A here. So thanks again for this great presentation, and also I think for a very interesting and diverse discussion as well. Just before we end, I think as a thank you, Paul, we are planting a tree in your name. We're not sure yet what kind of tree, but we'll let you know afterwards.
Thank you.
And also as a little connection to the next webinar, you already mentioned something about the public mental crisis, and I think that perfectly connects to our next topic. Because on the 17th of June, we will have Jaap van der Stel here as a speaker, and he will address all the emotions that are related to climate change and how to deal with that. So thank you, Paul, and thank you for the audience for being here. We had quite some people in YouTube, so that's great. And I hope to see everyone on the 17th of June.
Thanks so much. And thanks so much for the great questions. Wonderful.